All right. So I'm here to talk today about sort of a collection of stories that I've been keeping track of in my time working on recommendation systems. And you can kind of think of this as like sort of true crime TV, or like when they get hardened criminals to talk to juvenile delinquents to like scare them from continuing their life of crime. So this is your big warning not to do these bad things in your machine learning systems. Wrong clicker. Cool. So I'm Evan. I lead the data team at Meetup. You can find me on Twitter at Estola. So a little bit about Meetup. Most people in tech I find have heard of it, but just to kind of give you the background, we make real local community, and we provide a way for people to find people with similar interests in cities all across the world. I think these numbers are a little out of date. I think it's 26 million members, 250,000 Meetup groups. And so whether it's knitting or snowboarding or data mining, Meetup is the place to find it. And we're not just tech. This is a great story about a woman who was going to veterans meetups, and people kept asking her, oh, where did your husband serve? And she was like, no, I served myself. And so she made a group just for actual women veterans. And of course, we do a lot of tech meetups as well. So this is the National Day of Civic Hacking. This was meetups all across the country. We're participating in building things for their local communities. Tech meetups aren't just in New York and San Francisco and Seattle. There's hundreds of cities across the country that have tech meetups nowadays. These are a couple graphs I made in case you guys have been wondering if data science or data analytics is more popular. Data science is on the rise. It looks like it might catch everything within a couple years. These are topics added to Meetup groups. Machine learning has finally passed data mining. I remember when I first learned everything, I just took a data mining class. I didn't even know what machine learning was. But now machine learning is the coolest thing to say. It's true. Deep learning has I originally made this slide a year ago, and deep learning was still behind, but deep learning has passed neural networks. So way to go, deep learning folks. Neural networks don't matter anymore. And Spark is still on the rise, but has not come anywhere near to Hadoop in terms of popularity, at least on Meetup. So, and Hive is dead in the water. Poor Hive. Oh, I still like it. I still use it. So today I'm here to talk about recommendation systems. I imagine a lot of you know what recommendation systems are. This is a screenshot from Amazon, and I was looking at an Isaac Asimov book. They recommended 6 other Isaac Asimov books. Obviously very relevant, maybe not the most creative recommendations ever, but clearly they're on the right track. And this is probably based on this well-known algorithm, doing k-nearest neighbor, collaborative filtering. You have some distance metric, you find other people whose profiles look like yours, and then you extrapolate from the data about what they've bought that you haven't bought yet and assume that you should buy those things. The other major recommendation algorithm kind of comes from the Netflix prize, ends up doing matrix factorization, but ratings prediction is this other major problem in recommendation systems. And this is basically boring now. Like I've seen them talk a bunch of times. You guys probably have either like Justin from Netflix or Javier used to talk about how their algorithms have gone way beyond just ratings prediction nowadays, and all this implicit data and all these other things matter so much more. And this leads us to learning to rank, which is kind of the current cutting edge for a lot of recommendation algorithms. And sometimes I talk about this kind of stuff with slightly less technical groups, but I'm guessing you guys know most of this stuff already. But the cool thing about learning to rank is you can kind of use these search engine metrics to evaluate, using precision at K or whatever. And if you have 10 slots to show something to the user, you can actually find the best 10 things to put in the application. We already heard earlier about Facebook using diversity in the rankings. That's very much the sort of learning to rank approach, as opposed to just showing the n best things, all 6 Isaac Asimov books. So this is Google.com. You guys have probably seen this page. There's probably 6 different recommendation algorithms being used to power this page, right? Like even Google's base search is no longer just straight, text analysis and crawling the graph of links. We have ads on the side. We have this bar of sort of extra information, ads and whatnot. So this stuff it's everywhere. It's running the world. It affects the information that people can find. So one of the core things that I want everybody to sort of step back and think about is that the algorithms that we build actually impact people's lives at this point. It's not just the ads that you see, and as we'll see, the ads that you see can also have a serious effect on, your day-to-day, but the news that you're exposed to changes the way you think about things. The fact if a product is available to you or not. If you live in a poor area and you can't even get access to some product, is based on somebody's model somewhere. You can imagine there are certainly algorithms out there that are screening applicants into colleges, algorithms that are screening applicants for jobs. And these have real, legal impacts. You're literally not allowed to use certain factors in determining if someone gets hired. And this raises some ethical problems when it's a machine or an algorithm that's making that decision instead of a person. So this is something interesting I was thinking about, is how Google essentially learns to bias you based on how you query it. So if you Google Obama birthplace, they confidently reply Honolulu, Hawaii, in the United States. If you Google Obama birth certificate fake, 6 out of the 7 results, I think, actually think that he's not an American. And this is because if you search for something and then you click on a result, Google learns, people who search for that click on this result. And so even at this sort of base level, the information that we have access to, if you type something into Google differently, Google is smart enough to give different answers. This is going to sort of divide the world in some ways. This is an example from Amazon. You guys probably saw this. This is, somebody ordered a kitchen scale, and now Amazon's recommending them the drug dealer starter kit. This might not even be a real example, but I mean, it makes sense. If you're not sort of one of the sort of important things to take out of all this is that you can't just sometimes what's right. I mean, certainly a lot of people that are ordering this particular kitchen scale might be ordering rolling papers in little plastic bags. But that doesn't make it the right thing to output from your machine learning algorithm. And you have to take special steps to sort of avoid that. All right, so this is a story. Could you guys raise your hands if you remember this one? Orbit's Mac PC sort of problem. This was a massive story. Does anybody here work at Expedia, by the way? All right. I used to work at Orbitz, and I left Orbitz before they got bought, so I can still hate Expedia. But no, I'm just kidding. I'm sure you guys loved it when this happened. So the sort of full story behind this, especially because Orbitz is bought and I haven't worked there for years, I actually built this algorithm, personally. It wasn't search, it was just recommendations, and we'd done some analysis and showed that users who are on Macs are more likely to book 4- and 5-star hotels. This is pretty logical. They spent more on their machine, they're more likely to spend more on their hotels. And so we were like, maybe we should give different recommendations. And the context for recommendations was the hotel page. So you're looking at an individual hotel, and we have a spot at the bottom. We show 3 different hotels that you might like instead. So I did a very simple thing. I did our base collaborative filtering algorithm, and I just completely segmented the data. I said only Mac data applies to Mac users, and only PC data applies to PC users. And the algorithm did not win, and so I turned it off. And this happened before the story ever went out, but what happens is Orbitz invites in the Wall Street Journal, and they're kind of showing them around and talking about how smart Orbitz is, and they talk about how, we're so smart we even use whether you're a Mac or a PC in determining, what we show you. And it's supposed to be this article about how smart Orbitz is, and it turns out to just, the Wall Street Journal just slams them, right? Like total kind of gotcha journalism sort of thing. And nothing against the Wall Street Journal, it was a great story. But especially it was like behind a paywall, and the initial headline made it seem like they were actually charging Mac users more, which was never ever true. So I had actually left Orbitz like 2 weeks before I'd started my new job at Meetup out in New York. And my third day at Meetup, this story hits. The next day it's on Good Morning America. Like every news agency in the country picks up this story. And nobody had a screenshot. It completely was not happening. I was literally the only person who had ever used, whether you were Mac or PC, at Orbitz, and I had turned it off. And so this was crazy. I'm not at the company anymore. I'm like the only person in the world that knows what's going on right now, and every news agency in the country is running this story. And it took me years to talk about this because I couldn't figure out what the lesson was. I didn't know what the point was. I was like, don't trust the media? I don't know. And that didn't seem like the best point. I mean, maybe don't trust the media, but I finally figured out when I was thinking about this talk actually that the problem was the ego of Orbitz. And they weren't talking about building something for their customers, for their users. They were talking about how smart they were. They were talking about themselves. And so step one when you're building things for people is focus on them, not on yourself. It doesn't matter how clever you are as a data scientist. And this has a lot of sort of implications about, using fancy algorithms versus the simple algorithm that works and maybe isn't as sexy, but actually, does better or is easier to maintain or something like that. And so sometimes you got to kind of step back and put your own cleverness aside, I think. So this is a story from Google Ads that people with black-sounding names that were most likely to be associated with African-American people, were more likely to be served ads suggesting they had a criminal record, so rehabilitation from prison, that sort of thing. And I can't imagine, so we're going to get a little darker than the Orbit stuff, just so you guys know. I can't imagine what it's like, having the internet be prejudiced against me. It must be hard enough, going around the rest of the world, but with the sort of, the cloud judging me, simply based on my name, is just crazy. So, and this sort of leads me to the next thing of, we've accepted that if you're looking at a pair of boots and then the next day you're on a completely different site and those boots are on the sidebar, it's like, oh, how'd they know that I wanted those boots? Whatever, right? Everybody knows that. Your grandma knows that happens now. It's okay. I don't think that's ethics in machine learning. But there is a question of actual problems, actual things that affect people's lives or the way that people feel, as part of our society. And I think as the creators of these algorithms, we have an ethical obligation to do the right thing and not teach our machines to be prejudiced. So, big point. Just remember that you should talk about this. You should work with your organization, figure out what your ethics are. Make sure that your CEO and your CTO knows these things are possible, right? Like a lot of times in your organization, you might be the only one that understands how these algorithms work. And you might not be the only one working on them, but if we don't know that this can happen, we'll never properly prevent it. And so my first thing that I ask is that everybody think about this and make sure that your organization is sort of figured out where it stands ethically. And if you don't want to, we'll see the examples here. So our big issue at Meetup, the one that we've sort of taken a stand on, is women in tech. And we use machine learning at Meetup primarily for recommendation systems. So this is what you see on our homepage. This is what we email you about. It's when a group first starts in an area and we need to reach out to members who might want to join that group. That's based on a recommendation algorithm. And so pretty much a lot of the things that we do on Meetup nowadays are powered by an algorithm somewhere. And if we were to just let our algorithm infer whatever it wanted, it might very well infer that women are less likely to be interested in tech meetups. Like certainly they are underrepresented in them. From a certain point of view, that is a factual truth about our data. But that is not a truth that we are going to allow our algorithms to learn. And there's a couple steps that we take to do this. And I think that these could work in plenty of different areas. One is using interpretable models. So if our recommendations algorithm for a long time was a simple logistic regression, and we knew all the features that were being fed into it, and we knew that it wasn't going to be crossing certain features with one another. And this is a real easy way to know exactly what's going into your model and to keep things out of it that you don't want it to learn. This is our actual model. Well, this was as of a few months back, but so this is a logistic model. Logistic regression model is the weights for the different features, the topics and stuff. We do have a gender feature. Some groups can specify whether they are explicitly for men or for women. We allow our organizers to make that decision. But when gender hasn't been specified, we don't want to infer, that this is only, this knitting group is only for women, or this, tech group is only for men, just because that's what most of the members in it are. So, example of a good feature is you're interested in tech, and this meetup is about tech. Great, you should go to it. A good feature is this group is for women, and you're a man, so you probably shouldn't join it. A bad feature is don't join this group because it's mostly men and you're a woman. Like, that feels a little icky to us. Like, maybe our recommendations would be better if we allowed that, but we've kind of made a stand that that doesn't matter to us. And a horrible feature is to take that next step of inference and say, oh, you're a woman, so you can't be interested in tech. So we won't allow our algorithms to sort of continue to propagate these gender stereotypes. The other way we do this is through data segregation using ensemble modeling. And this is really similar, again, to what we heard about from Facebook earlier, where you can use strong algorithms and output something in as featureizes and use that in some sort of algorithm that you have sitting on top of them. And so this looks like this for us, where we keep interests and gender in separate algorithms. And the algorithm that ends up combining that information is never aware of the individual features that go into those sort of pre-algorithms. And from that, even the fanciest algorithm cannot infer that women shouldn't be interested in tech. Another example of sort of sexism that has come up in an algorithm was this group out of Carnegie Mellon created a tool called AdFisher that basically created fake profiles and searched around the web and kept track of what ads Google was showing them. And they found that they had two different groups that they were using, and one of them was way more likely to be shown ads for this executive training program, learn to get high-paying jobs sort of things. And the only difference between the two profiles was whether they had specified if they were a man or woman. And I think this is just wrong. And maybe advertising is a sketchy area already, but certainly you wouldn't want to be doing this by accident, I don't think. And I think if you're doing it on purpose, then when somebody calls you out on it, you should feel bad and shame and stop it. So I think this kind of works, and I think we'll be hearing another talk about an approach very similar to this, actually, well thought out technical approach, not just me hand waving. But this same technique can use for your own algorithms. If you're not clear on whether your algorithm is accidentally, using gender or race or something like that, and there's a lot of ways to accidentally use gender or race. So if you're using name, if you're using zip code, this is highly correlated with race in a lot of areas. And so you can create, these profiles and run your algorithm against it and see if it treats the two groups differently without ever actually giving your algorithm the data that you don't want it to know. And by doing that, you can figure out whether your algorithm is actually racist or not. Here's a harder problem. This is a story about, I think, Google Photos, not to keep ragging on Google, but accidentally tagging a black guy and his girlfriend as gorillas. And this is just mind-blowingly awful, right? And Google did the right thing. They immediately turned the service, they fixed it really fast. But there's a question of why did this ever happen? How can you prevent it? So there was a brief discussion just before this about the tape program. And you're using data from Twitter aren't that bad, but together they paint a really clear picture, right? Like maybe the rolling papers you can sort of try to pre-tag as sensitive. So we have that. So I don't know if you guys know this. There's some weird stuff on Meetup. Like there's like nudist groups and beyond that and whatever. And we're like, hey, cool, party, yeah, you know, that's great. But maybe we don't want to show that to, you know, the average user. And so we have those things pre-tagged as being sensitive. And so they're down-weighted in most of our algorithms unless you've, you know, shown some engagement with those types of topics before. And so I think that's the, you know, it's a manual process. I don't know of any way to automatically, you know, I guess once you have some, then you can do clustering, and I don't know, you guys can figure it out. It's good. That sounds like a fun problem. But, you know, you definitely have to think about, you have to imagine it happening in order to figure out a solution, certainly. Cool. Thank you. There's a conference called FAT-ML, Fair, Accuracy, and Fairness, Accuracy, and Transparency. Very cool. All right, I have 1.5 minutes. Sure. Sure. So, yeah, that's awesome. Yeah, so the point was kind of about you know, the relationship between journalism and machine learning, and how do you, you know, if you work for a website and you write stuff that you don't understand. I mean, maybe you heard about the issue with Facebook this, you know, the past couple of weeks with the you know, the sort of journalistic integrity or whatever, if that's what you want to call it. But yeah, it's a very interesting question. I think that's sort of that idea of design and your tools, you know, how they relate to the people that are using them and the, you know, members that are consuming them really matters. And so you have to sort of, unfortunately, dig into the business side a little bit if you want to be the best. So.
We have 2 hours to discuss all this.
Yeah, please come find me and talk to me. Thank you very much.
And if you like this talk, go to my vote.